Okay, in this next section, we're talking about factoring. This is all of Unit 4. And we're not solving. Notice it just says to factor completely and then stop. So one of the most common is our basic trinomial factoring. We've used a little tool here called this X factoring or diamond or whatever you want to call it. But we're thinking to ourselves, what times what equals negative 24 and subtracts to give us negative 5? Hopefully you're thinking of 3 and 8. Which one's going to get the negative? 3 minus 8 equals negative 5. So my factors are x plus 3 and x minus 8. Notice it just says factor, so we stop here. We do not solve. Now I'm going to skip over to part C, which is also x factoring, except that there is a coefficient greater than 1 here. Because of that 5, you have to remember that we are going 5 times negative 8 in the top here, and then negative 18 in the bottom. So think for a second on what times what equals negative 40 and subtracts to give us the negative 18. Hopefully you're thinking 20 and 2. 20 is going to get the negative. Now this is not x minus 20 and x plus 2 only, because there is a 5 here. We have to remember that that 5 coefficient needs to go as part of our factors, and we need to reduce it out if possible out of one of them. So notice that the 5x plus 2 cannot reduce at all, but that this one right here can reduce. A 5 goes out of 5 and a 5 goes into 20. So this one right here is going to reduce down to x minus 4. So when we're looking for our factors on a test with this one, remember that one of the hints that I gave you guys was to multiply out the answers to look for your correct factors. So if you're having trouble with the factoring of the bigger ones, just multiply out the answers to find this correct result. And here are my 2 binomial factors. Okay, letter F, B, and D are all special kinds of factoring. If you recognize that they're the special kind of factoring, you may not even have to do X factoring. So what times what equals 25 and then subtracts or adds to give me negative 10? Well, 5 times 5 equals 25, but I need there to be negatives for this. So x minus 5 times x minus 5 are my factors, also known as x minus 5 squared. So what is this called? This is called a perfect square trinomial. And you guys are eat, breathing, and sleeping perfect square trinomials when you did your completing the square, where you'd say half of 10 is 5, 5 squared is 25. And so how do you recognize a perfect square trinomial? It has a perfect square at the front, a perfect square at the back, and it has a double middle term. All right, well, what's the special kind of factoring for B and D? This one is not a trinomial. It's not a perfect square trinomial. This one is called the difference of perfect squares. And what denotes this one is that we have a perfect square at the front and a perfect square at the back with a minus. That's why it's called difference. And we notice there's no middle term, so there's got to be something about the signs. So what times what makes x squared? And what times what makes 36? And the signs have to be 1 plus and 1 minus in order to cancel out that middle term. So there's my difference of perfect squares factors. Now that we've seen that one, we can go down and do part D, which is a more complex version of B. Notice that 4x squared is 2x squared. And notice that 81 is 9 squared. So 2x times 2x is my 4x squared. 9 times 9 is my 81. 1 plus 1 minus to make sure there's no middle term. Those are your perfect difference of perfect squares factors. Some people think of it like the square root of the front and the square root of the back. right, finally, grouping, factoring by grouping. This was the one where I had you guys break out each term. Where you could say 2x to the third is 2 times x times x, 2 times 2 times x times x, 2 times 2 times x, 2 times 2 times 2. But you're going to notice that there is not anything in common all the way down. And so we have to break this into two separate groupings. So first, what's in common with the top? I see a 2 in common. I see an x. I see an x. So we've got 2x squared in common. And then what's left over goes inside. All right, how about the other one? I see a 2 in common, another 2 in common. So 2 times 2 makes 4. And then there's an x minus 2 left over again. If you have done factoring by grouping correctly, this grouped part should be the same. The leftover part should be the same. Final answer, you take the 2x squared plus 4 and the x minus 2, which is in common. Actually, I'm going to write this the other way around. We take what's in common out front. I see the x minus 2 in both, and then we put what's left over at the back. There are my factors by grouping. What if you're not good? What if you're not very proficient at this method of factoring? Remember, you can always take the answers and multiply. Okay. Now, I just realized that in this entire factoring review, there is nothing in here on greatest common factor. And so the greatest common factor of something like x squared, 8x squared, minus 32x, and we want to find the factor, we're going to look at what can divide out. So hopefully if you look at this, you see that an 8 divides out and an extra x. So that common factor goes in front, and what's left inside is 1x. Then 32 divided by 8 is 4, and the x is crossed out. This sign in the middle of negative goes down here in the bottom. Let's double check our answer. 8x times x does give me 8x squared. 8x times negative 4 does give me negative 32x. What's another way I showed you how to do greatest common factor? Just like we just practiced in the grouping, we break it up into its smallest parts and find what's in common. So this, and this. 2 times 2 times 2 in common in the front and an x. And what's left over inside is the x minus 4. So this becomes 8x times x minus 4.